Everybody, welcome. Just to introduce myself, I'm Roger Cressy. I'm the host for today's Analytics and Data TechCast. I'm one of the founders of Cubics International. We're an Oracle Platinum partner operating around the world, implementing and developing ERP, EPM, and BI solutions alongside our customers. So really the important part today is I've been volunteering alongside many amazing people in various capacities with the Analytics and Data Oracle user community. We're a group focused on getting and sharing good content with each other and knowledge. It's an honor to be involved with this community. I'm thoroughly enjoying the relationships and participation that I'm learning and growing in with the folk around me. So today, just to get on with it, we've got a presentation, graph analytics, an example of detecting fraud in the financial industry, is going to be presented by Melly and Gautam. I'll give more detail on them in a minute. But just really for purposes, and I'm not sure, Gautam, if you have that slide, we do have some useful tips and places to go if you have, we supply them on the deck. All of the decks the deck and the recording of this TechCast will be put up on our website. So you'll be able to find all of this in the future if you have to jump off before you're finished. And we also, just so you're aware, on the web, on the TechCasts area of our website, you'll find obviously the archive of past TechCasts, but you'll also find an area where you can submit your own abstracts for consideration. We're always interested in people sharing their knowledge, and real life cases are particularly interesting. Our next TechCast, sorry, getting all muddled up with my mouth. Our next TechCast is scheduled for August the 6th after this, and that's going to be Maria Colgan speaking on the future is data-driven. The last sort of series of TechCasts, we had our TechCast days between the 7th and 9th of July. You'll find a lot of amazing content from those 3 days. Each day was sort of 3 hours of intense sharing by real experts in the industry. So please feel free to go and have a look. I think you'll find a lot of good knowledge to be gained there. So you'll be able to, obviously the speaker's contact information you can see on the screen right now, and this deck will be uploaded. Just in terms of how we operate the TechCast, if you have questions, please don't put them in the chat. There is a specific Q&A area. If you put your questions there, we'll attempt to answer them during the session. Any of the questions that are not answered, we will get to Melly and Gautam afterwards, and we'll get answers to you via email or something of that nature instead. So without further ado, let me introduce the speakers. We have two today. The first is Melly Malai, is a product manager at Oracle. She's got lots and lots of experience in multiple technology areas related to unstructured and semi-structured data management. One of her current focus areas is big data, with an emphasis of integrating data from streaming sources and Hadoop environments with Oracle database. She works closely with customers as they deploy solutions using Oracle big data products. And she's a regular presenter. She's presented for us before as well at Oracle Open World and at other industry events. So moving on to Gautam. Gautam Pisharam is a senior solution engineer at the Oracle SE Hub, and he specializes in multi-dimensional analytics of high volume data. He's definitely one of my favorites because he's worked with Essbase. So he works with data science teams of customers across the globe, helping them identify graph network patterns and cycles using compute-intensive algorithms. And yeah, he believes in making visual communication of data simple, intuitive, and business-friendly. So without further ado, let me hand over to them. I believe Melly's going to speak first, and Gautam's driving. So I'll turn off my camera and hand over to you. Happy hunting.
Thank you very much, Roger. And thanks to everyone attending. It's great to be here at yet another TechCast. So Gautam, if you could go to the next slide, please. I just wanted to start with kind of a recap of graph analytics. We've presented graphs at this TechCast, and you might have seen other sessions and so on, but just wanted to do a quick recap, and then Gautam will do the bulk of the session focused on one specific use case. Next slide, please. So graphs are a different way of looking at your data. It's a way of looking at your data through the connections and relationships between data entities. So looking at your data in this way gives you the ability to get additional insights into your data. And graphs are being used in a variety of industries and the thing to realize here is that almost any data set can be viewed as a graph. You can make the data entities in your data set as nodes in a graph and the connections and relationships between them as edges in the graph, giving you the ability to get new insights into your data. So in the financial services industry, for example, you can look at user accounts as nodes and financial cash transfers between them as edges. In manufacturing, bill of materials are modeled as graphs to help understand the complex interconnections and dependencies between different components that are used to build, let's say, a phone or a car, so that you can answer questions such as, when I change one component, what is the impact on the rest of the components I have in this bill of materials? In law enforcement and security, it is used to identify connections that might not be direct connections. So identifying new connections for a suspect would provide more insights into what is happening in your data and so on. So graphs are, you can think of graphs as a way to have a logical network on your data, and any data can be looked at as a graph. Next slide, please. So I was talking about, this is the financial services industry, so I wanted to just quickly talk about one use case before we get into the bulk of the presentation. And I did present with Paysafe a few months ago, so this is just a quick recap of what we had discussed then. So Paysafe, like many other financial services enterprises, they're very interested in detecting fraud. They are a payment solutions company, and they use the simple model that I was just describing, where their user accounts are nodes in a graph, and every time there's a cash transfer, that becomes an edge in the graph. So to identify fraud, before they use graphs, to identify fraud, they were using somewhat of a manual process, and that would take hours and days. With the help of graph technology, they were able to automate that, so it now takes seconds or milliseconds to identify anomalous patterns. So that's what graphs are good at. They look at all the cash transfers, all the activity as a graph, and identify where there are some unusual patterns. Like you can see here in the figure on the left, there is cash being transferred from this account to this account, but goes through a multiple intermediate accounts. So maybe there is something from transactions that are trying to be hidden, or maybe they're trying to cross maximum transferable limits and so on. Like on the right, once again, you have a lot of user accounts, and a lot of cash transfers, but relatively few number of source and destination accounts. So these are anomalous patterns that they're able to detect by running graph algorithms on the data that they're viewing as a graph. Next slide, please. Next slide, please, Gautam. So just a recap on the features that we have. Sorry, could you go back, Gautam, to the features? Thank you. Just a quick recap on the features. So when you're working with your data as a graph, you of course need the way to store, manage, query, and analyze graphs. So at Oracle, we have graph databases and graph analytics support. Built on Oracle infrastructure, it's designed to be highly scalable. And when you are working with graphs, you need a way to query graph patterns. So we have the property graph query language, which is a SQL-like language, which has the ability to specify graph patterns. And I think Gautam might be showing you some examples. And we also have over 50 pre-built graph analysis algorithms, things like PageRank, between centrality, clustering algorithms, Dijkstra shortest path, and so on. These are pre-built algorithms available as a Java API. We also have a lightweight visualization tool that you can use to visualize graphs in a browser. And with that, I think I'm going to hand over to Gautam.
Thanks, Melly. Thanks for the overview. All right. So in today's session, we'll be mostly focusing on how to detect fraud in a financial transaction. Fraud. When we discuss about fraud transactions or fraud in financial transactions, it's usually very sensitive in nature because there is a lot of IT laws and regulations involved in detection of crimes related to financial transactions. So one way to detect fraud in a financial transaction is to see if we can discover suspicious patterns in it. And one way to detect suspicious patterns in financial transactions is to see if we can detect financial cycles in it. So before getting to know how cycles can be used to detect financial fraud, we need to first know how cycles can be used to detect opportunities. So we'll be first looking at how we can deal with opportunities and risk related to cycles. Customer. So customer comes very first to any financial organization, or for that matter, for any organization, customer comes first. In today's world, customer first is the very go-to strategy, right? Now, what we want to showcase here is today's modern day customers. When it comes to a banking customer, they are like very much well empowered. They are like very well socially connected. They access their day-to-day life related activities through mobile applications, or it's very easy to leverage financial services to make sure a lot of their day-to-day activities are performed using the financial services. So when we try to focus on socially connected, if you look at countries like India or US or a densely populated country, people have started using mobile applications to socially connect themselves between different customers and make transactions. So we have financial applications in which we can transfer money to our friends using the banking applications, and we have third-party applications as well, which will facilitate the banking transaction between different people. So if I need to transfer money to my friend, I can just use an application to transfer the money, which will directly get transferred from my bank account to my friend's bank account. Now, where this is getting benefited is that if a customer wants to go to a supermarket and he wants to buy certain good stuff for him, he can use either a mobile applications or he can use various mediums like a credit card or a debit card. Now, to secure the life, he can probably secure a personal loan or a professional loan, all by a single touch by just logging into the mobile applications as well as the internet net banking. So to summarize here, to see how banks are impacting the day-to-day activities of a customer who is the customer of a financial banking institution, they provide a lot of financial services in which it becomes very easy and transparent for the customer to make a lot of day-to-day activities. Now, if you try to think it in a reverse way, wherein how to see and how to understand a financial banking institution impact a customer's life, and how a customer can impact the day-to-day life of a financial banking institution. What we can do here is, so let's take the example of a fintech company. What happens here is if we want to study how a day-to-day life of a financial banking institution is impacted by a customer, let's try to see the latest technology for strategies implemented by the fintech applications. What usually happens is when I transfer money from my bank account to my friend's bank account, it is sort of developing a trust factor or a loyalty factor between the various customers and the banking institution. And what happens here is when we try to leverage the financial transactions by transferring money between different people using the various financial applications, over a period of time, they can offer recommendations to various customers. Now, let's say, for example, if I'm transferring money to my friend, and just because I transferred money to my friend using a financial applications, my friend will be offered recommendations from different sites with which he can use his credit card or debit card, or even make an online transaction by leveraging the offers with different retailers and the sellers. So banking applications, by the support of fintech technologies, they leverage various machine learning modules in the background to make sure they can offer recommendations to various customers in which the financial services will be leveraged and more customers will be encouraged to leverage the financial services modules. Now it's obviously directly crediting to the profit of the financial banking institution as well. So we are discussing about how cycles can be used in creating opportunities between the customers as well as banking institution by leveraging the various technologies of a fintech company. If you want to get into the third case, so we were dealing with the positives of creating opportunities with the latest technologies included, which make sure the customer first and technology first strategy will be benefited a lot. We also look at how we can create risk by the same cycles included. Let's say, for example, if a group of friends are transferring money between themselves, and over a period of time, they'll be making credit card transactions, they'll be making debit card transactions, they'll be logging into the net banking, they'll be making a lot of online transactions. Now, over a period of time, just because they have developed a sense of trust or loyalty with the bank, the machine learning in the background will be learning the behavior of the customer patterns, and all these customers will be offered different recommendations by the system. So they'll be able to use their credit cards or debit cards for more offers, and most of these customers will be eligible for a quick loan disbursement as well. So they can just log into the net banking, they can disperse a loan amount, a big loan amount, and it will be immediately credited to their bank account. One good thing of enabling the trust between the banking sector and the customers is that the customers get instant access to leverage the loans, and it will be quickly dispersed into their bank accounts, which is obviously increasing the trust factor between the customer and the banking institution. But then what if a false sense of trust is developed between the customers and the banking institution? So let's say, for example, if the customers try to establish a false trust by making sure they have a continuous inflow of money in every customer holder's account. So basically, customer A will transfer money to customer B. Customer B will transfer the same money to customer C. Customer C will transfer the same money to customer D. And customer D will transfer the same money back to customer A. That's what we call a cycle. So if they try to simulate this financial cycle over a period of month, most probably their bank accounts will be offered recommendations in which they'll be able to leverage their credit cards, or they'll be able to log into their net banking and then disperse a big loan in a very quick way, even without the verification, because their credit scores or the loyalty score is very high. And these fraud transactions or fraudsters will basically take the offer, they basically disperse the loan, and then they just vanish away. So the banking institutions are recording huge amount of loss or millions of dollars of loss every year in dealing with fraud transactions. And one way to detect frauds in financial transactions is to see if we can discover the suspicious patterns between the different customer accounts. And once we identify The suspicious patterns, most probably it will be following a cycle, which is what we'll be discussing in this particular session. So let's see how we can translate graph in a Oracle graph perspective. So from this particular image, let's look at the extreme right of this picture, wherein we can see that the person Liam, who is the owner of account 2090, is making a transaction close to $10,000 to the account 10039, and that particular account makes another transaction of $1,000 to the account that is mentioned below, which is 8021, and it belongs to the owner Nikita. Nikita, in turn, using that particular account, makes a transaction of $1,500, also makes a transaction of $3,000 to the fourth account, which is 1001. And then from that particular account, close to the initial transaction money, which was $10,000, goes back to the original account which initiated the transaction, which is again 2090. We can also see that the owner of account 1001 also is owning a company, and we can see that Camille, a different person who works for that particular company, is the owner of one of the financial accounts. So if we look at in a general perspective, this graph, which is by the name financial transaction, is making transactions between different friends, and that completes a cycle. So account 2090 transfers money to 10039. From 10039, there is a transfer going to 8021. From 8021, there is a transaction going to 1001, and from 1001, it again goes back to 2090. So the money basically comes back to the same person. Now it could be possible that Nikita will be transferring different amount to Camille, who is the owner of the account 1001, using a different account, or the account 10039 may be making a different financial transaction to 8021 through a different account as well. And that could be one reason why they might be getting the money close to the initial transaction back to the account which originally initiated the transaction. So this could be suspicious in nature, and this could be deemed as a financial transaction with a suspicious pattern, and this could be then sent for further investigation. How we can get to know more details from a graph perspective or from an Oracle graph perspective? We have the name of the graph, financial transaction. So graph has graph is basically establishing the relationship between the vertices and the nodes. So in this particular example, the account name is the vertex of the graph. Then Liam as a person, he is the owner of an account. So owner of account becomes the edge of that particular graph. Person who is owning that particular account, it becomes the property of that particular vertex, which is the label of the vertex. So vertex is the account ID, and person is the label of that particular vertex or property of that particular vertex. Then we have property of the edge. So owner is one of the edge, and then he's making a transaction to a different account. So that becomes, transaction becomes the property of the edge, or it becomes the label of the edge. And then we have the property of the vertex as well, which is basically the account number. So account ID is the vertex, and the account number is the property of that particular account. And then we have the property of the edge as well. So if I'm transferring money to a different account, the transaction that got transferred from one account to another account becomes the property of that particular edge. Let's try to see how this polishing plays through a demo. So I'll go to the Oracle visualization. So what we are seeing on the screen is a web-based graph visualization, which is reading the graph from in-memory of the graph server. So there is a server where we have installed the actual graph server, and we have loaded the graph into in-memory, and using the web product, which is called as the graph visualization, we load the graph from the in-memory into the web visualization. Now, if you look at this particular graph, we can see multiple details. So starting from the right-hand side, 201 is the account holder. So we can see that 201 owns a particular account, which is 101 to the left. We can also see that there is an account holder 202 who is owning the account 102. So we can see that there is a cyclic transaction between the accounts 101 and 102. So 201 is the account holder. He is holding the account 101. Similarly, 202 is the account holder who is owning the financial account 102. And between them, they are making a transaction. So there is a transaction happening between two of the financial account. We can also associate different properties for the vertex as well as the edge. So we can see that 203, if you take the example of 203 as an account holder, he has a telephone number. He also has an email. And something suspicious here is that 202 also share the same email ID with 203. So these are some of the examples wherein they could really detect something like a suspicious pattern between different customer accounts. They could be using the same email ID to make sure they try to expand their network. So when it comes to cycles, there are concepts like homophilic transactions or heterophilic transactions. So homophilic transaction stands for when a customer tries to extend their circle into some immediate members. That's something which is called as a homophilic transaction in nature. And they might be using the same details to extend their relationship with different customers. It could be a fraudulent activities as well. So when they're extending like that, it could be a sign that most of the customer accounts could be hacked and they're being used by a different person logged in from a different place as well. So these could be deemed as suspicious patterns. Let's try to look into the cycles in detail. And let's see how we can use the PGQL language to generate the cycles as well. So in this graph visualization, I also have a dedicated pane to paste my queries and run it against the graph that is loaded in the memory. So now I'm trying to run a PGQL query. And if you can see this, what I'm trying to do here is I'm trying to match a pattern wherein I want to get details wherein customer A has transferred money to customer B and customer B has transferred money back to customer A. And I want to visualize all the customers as well as the edges. So from the previous example where we were basically seeing the entire details of the graph, we just try to detect the cycles from that particular financial transaction. So if I have to recap what we just did, if I copy this particular code and I run it against the in-memory graph that is loaded, this is basically taking the entire graph from the memory wherein every transaction is recorded. Now from this particular graph between different people and their transaction, I just want to generate a cycle in which customer A has transferred money to customer B and customer B has transferred it back to customer A. So I'm just interested in taking that particular cycle. Now, when we get such a cycle, the graph visualization also helps you to apply various formatting on top of it. So let's take an example. Let's try to apply a conditional formatting here. If I want to quickly identify transactions that are larger than a specific value. So let's say I want to highlight and I want to redline all those transactions above 150. I can just go here. I can say greater than 100. I'll select a color. I'll select the red color. I'll add the highlight. Click OK. And now we can see that the transaction, which is basically 150, is now highlighted in red color. So the intention of showing you this is to understand how a graph looks like within the graph visualization and how we can leverage the graph query language to detect the cycles from a financial transactions. So later towards the slide, we will also have details on the importance of finding the cycles as well, or why it is so vital to detect the cycles in order to detect the fraud transactions. If you want to detect fraud, you need to make sure you detect the cycles, or you need to detect the suspicious patterns. Let's get into some more advanced way of looking at graph. Till now, we only looked at a very simple graph. So I'll show an example of a complex cycle. So I'm going to run a query. So the query is that I want to detect all the cycles between different people in such a way that customer A has transferred it to customer B has transferred it to customer C, and customer C has transferred it back to customer A. So it's a 3-node cycle. So it has basically taken from the in-memory all the information related to a 3-node cycle, and I'm displaying information on all the customers and their respective edges. So I can see that, for an example, customer 502 has transferred it to customer 203. Customer 203 transferred it back to 962, and 962 transferred it back to 502. So this is an example of a 3-node cycle. And what we can see here, I'm trying to limit it by 10 cycles. So it is basically taking the first 10 3-node cyclic transaction. So what happens when I try to delete that limit and then try to run? So now it is trying to take all the 3-node cycles from the graph without any condition. And now we can see that there are a lot of cycles, or a lot of 3-node cycles from this particular graph. Now this becomes quite difficult to interpret, because it's usually a time consuming process to detect the cycles and then detect the meaning from those cycles. So let's try to see how we can make it even more simpler by trying to run certain insightful queries against, rather than just trying to find out all the cycles involved.
Just so you know, you've got about 5 minutes or so, 6 minutes odd left, Gautam.
Right. Thank you. All right. So rather than trying to focus on running a query against the full set of cycles, we are now trying to identify the shortest paths between a 6-node cycle, which is starting from a node 1. Or basically, we are trying to focus into a very specific customer node by the account number 1, and we are trying to take the shortest path, which is identified as a 6-hop transaction. So if you look at the second line, we can see that there is a 6-hop transaction between 6 nodes and 6 edges, which was initiated by the customer 1, and then it comes back to the customer 1 with different people involved. Now, if you want to identify the actual transaction with 6 hops between these customers, let's run a different query. So trying to identify the patterns between customer 259 and customer 1. And then we'll quickly be able to identify that particular query. Let's try to probably run one more advanced query. And now, if we want to identify cycles in such a way that we'll just try identifying the end point of a 6-hop cycle, starting from the customer with the account ID 1. So trying to match a pattern in which customer 1 has made a transaction with 6 customers, and we are just taking the final hop here. And we can try to visualize it in different ways as well. So let's say, for example, you want to discuss it in a circular way. And this basically lets us visualize it in a different pattern so that it becomes very easy to detect the cycles between different customer accounts involved. We can also try to visualize it in a grid format. And here we can easily see that the customer is involved in different transaction with customers in different grids as well. So the graph visualization can be used in a very insightful way to detect the various cyclic patterns between the customers. So I'll get back to the presentation now. This is just to highlight the framework of a fraud analytics solution. So if we look at step 1, we collect the raw data of the financial transactions between different customers. We try to put it in a database in a very structured format. And once we have the data ready in a structured format in a database, we then generate a graph schema from the transactional data. So it basically generates the vertex tables and the edge tables. And once we have the vertex tables and the edge tables, we then try to load it into the in-memory. And then we try to run few algorithms on top of the in-memory. And then we try to visualize it on the engine. To highlight different approaches, we can either load the data from raw data into the relational database first to make sure we have a structured database ready, and we can then generate the graph schema based on it, and then we can load it into the in-memory engine. And from the in-memory engine, we can then visualize it using the graph. A second approach is to load the data from raw data into the relational database, and without generating the graph schema, we directly load the data from the database into the in-memory and then try to visualize the graph. The difference between both these approaches is that, as we can see, so approach 1 is taking a long step. And if we try to equate it with the picture, it's the ants trying to go in a very steady way. It's like a digital ecosystem for the complete graph cycle. If the customer is looking at a very long-term graph implementation, it's recommended to go with an approach wherein they have a graph schema and they have a very proper vertex table and edge table. If you want to enable the data scientists to create the graphs much faster, what they can do, they can directly load the data from the database into the in-memory, and then they can run the algorithms, or they can write the PGQL queries and then get the cycles on top. So it's a comprehensive platform to consume the data quickly from the different data sources. So graph server can be loaded with data from a database directly by using a configuration file. You do not really need to generate the vertex table and edge table if the requirement is to make sure the data scientist can create the graph models in a much faster way. So how is Oracle Graph different? The first would be the scalability and the performance. Since it is directly connected to the database would be acting like a structured form of data source wherein they can get all their financial raw transactions. Without having the financial raw transactions, we'll not be able to detect the cycles. And without having a medium to easy and accurately detect the cycles, we'll not be able to detect the suspicious patterns or the financial transactions. And then with the help of the built-in graph algorithms and the graph visualization, we'll then be able to generate the insights on the suspicious patterns as well. So one thing which I really wanted to highlight is on the graph algorithms as well. I'll probably take 2 minutes here. So rather than just having the query, something which is very insightful is that we have different centrality measures associated with the graphs. So something like a degree, the degree associated to a customer. So how many people can a person reach directly within his circle? That's the degree associated to the customer. We have centrality measures like betweenness. So betweenness is more like how likely is a person to be the most direct route between two people in the network in identifying the fraudulent transactions. We have the centrality measure like closeness, which is basically like how fast can a person reach any other customer in a network. We also have centrality measures like eigenvector, which is like how well is a person connected to a well-connected different network. We then have the PageRank algorithms to find the influencers, or we have the digital algorithm to find the shortest path. So a lot of built-in algorithms are there to make sure you can run in algorithms on top of your in-memory graph and then find the insights on the suspicious patterns. The last point, which is on the model consumption, because of the connectivity between the database as a source to the in-memory graph model, every business insights can be generated between the data scientist or a data professional, between the developer, between the business analyst, between the business executive. So the whole platform can be leveraged by different analytical firms within the organization and can be consumed directly with the help of different tools within the Oracle graph. Having said that, I'll hand it over to Melly to complete with the links.
Thank you very much, Gautam. So here are some of the resources you can have to learn more about graphs. I just wanted to ask you one question. I believe your experience came from working with an actual bank, right? I believe their data size was in something of 300 million nodes and edges, if I remember correctly. So you're working with a very large graph, looking at around 2 months of data, I believe, at this bank, right? So this comes from real experience of working with that customer, if I remember correctly.
To give more details on the financial transactions that were involved with the real bank, we were dealing with around 100 million customer accounts, and we were dealing with their 300 million transactions between the customers. And that's one reason why we are specifying on the importance of detecting the cycles and the importance of having a scalable system as well, because the system should be able to scale transactions of close to 300 million transactions, and that's only 2 months of data.
Right.
And we were really able to detect the cycles from the huge data set.
And this whole the cycle detection thing really complemented what they were already doing with machine learning. I remember discussing that, as you were pointing out earlier.
Right.
So.
Right. So like I highlighted, like cycles can be used to generate opportunities with the machine learning happening in the background, but then you can defraud the bank as well. And cycles can be helpful in detecting the suspicious patterns in identifying those fraud transactions as well.
Thank you very much, Gautam. So over to you, Roger.
So thank you so much, both of you, Melly and Gautam. It was really interesting. It's always good to see something real. Appreciate your efforts, Gautam, with something that was live. So just for everybody on the call, these the questions, actually there were some questions, but they've all been answered with the individuals involved. These are some helpful links. I did post also the TechCast page link on the questions and answers as well. So without further ado, I just remains to say thanks very much to Melly and Gautam again, and I hope you all stay safe and have a good rest of your Thursday. Thank you, everybody. Bye-bye.
Thank you. Bye.